Hello, and welcome to today's SEI webcast, Generative AI and Software Engineering Education. Today's webcast is a part of our Software Engineering Educators series. My name is Shane McGraw, Outreach Team Lead here at the Software Engineering Institute, and I'd like to thank you for attending today. We want to make today's webcast as interactive as possible, so we will address questions throughout today's panel. You can submit those questions in the YouTube chat area now, and we'll get to as many as we can. Now I'd like to turn it over to Dr. Grace Lewis, one of the organizers of the SEI Software Engineering Workshop for Educators. Welcome, Grace.
Thank you very much, Shane, and welcome everybody to this very first webinar in the Software Engineering for Educators series. My name is Grace Lewis. I'm a principal researcher at the Software Engineering Institute, and I've been co-organizing this workshop for 20 years now with my colleagues, Rod Nord and Tapajit Day. This marks the very first webinar, as I said before. It's something that we're trying out new this year to reach a much wider audience than we have before with our workshop. And with that, I would like to hand it over to my very dear colleague and friend, Ipe Koskaya, who is going to lead us through this very first webinar in this series. Good luck, everybody.
Thanks a lot, Grace. Hello, everyone. My name is Ipe Koskaya, as Grace mentioned, and I'm the technical director of a team called Engineering Intelligence Software Systems at the Software Engineering Institute. We are very excited about the topic of today's webinar because, as we all know who've been working in software engineering, generative AI hit software engineering hard. There are all kinds of opportunities as well as challenges. We at the SEI also work in some of these aspects, especially from a software engineering perspective. Thankfully, the initial surge in excitement and fear around generative AI gradually is giving its way to more realistic perspectives. We have seen several recent studies that provide better balanced views, reflecting insight from developer discussions about the extent to which GenAI-supported tools meet the expectations of software engineers. These studies also offer more concrete examples of how GenAI can be incorporated into software engineering tasks. While the jury is still out on the actual return on investment and tangible improvements, the rapid pace of change of models and services is also challenging software engineering education and educators. Educators in many institutions, those of you who are in the audience will probably know way better than myself, had to adapt to ongoing development of the tools and provide a very realistic perspective to their students, both balancing awareness, skepticism, as well as curiosity. So today, while I'm not an educator, I'm going to be playing one as the facilitator, although I do see some of the aspects of the skill set, skill development, how to bring some of these skills into software engineers in organizations as well. And fortunately, the inaccurate narrative that GenAI would displace software engineers has given way to a more constructive discussion around the necessary skill sets. And that's why it also becomes very important to think about the educational curricular aspects. So today, I'm joined by two experienced software engineering educators who've been experimenting with using GenAI in the classroom and thinking about how it should and should not impact software engineering education and software engineering workforce, Dr. Doug Schmidt and Dr. Michael Hilton. We invited Doug and Michael precisely not only because of only their in-classroom experience as educators and very experienced educators, but they also bring industry, federal research such as DARPA, and software engineering leadership experience to the discussion. Doug is the Director of Operational Tests and Evaluation for the Department of Defense, and formerly he was a Cornelius Vanderbilt Professor of Engineering, the Associate Provost for Research, Development, and Technologies, Co-Director of the Data Science Institute, and a Senior Researcher at the Institute for Software Integrated Systems, all at Vanderbilt University. Clearly, he brings a perspective from multiple stakeholders' experiences. He was also a visiting scientist at the SEI, and those of you who've been paying attention will know his name. He's internationally renowned for all the work he's done, especially in pattern-oriented middleware, Java concurrency, parallelism, and more recently focusing on generative AI. Michael is an associate teaching professor in the Software and Societal Systems Department in the School of Computer Science at Carnegie Mellon University. He's also the Associate Department Head for Education, as well as the Director of Software Engineering, Minor and Concentration. He holds a PhD from Oregon State University, and he teaches a variety of courses each year, such as Foundations of Software Engineering and Software Engineering.
I can talk about some of the classes I teach. I teach a variety of classes, including Foundations of Software Engineering, which is our flagship software engineering course. I also teach software engineering for startups. I teach a software engineering capstone class, and I even teach a software engineering course for non-CS based students. That is a lot of fun to teach. So I have been teaching here at CMU for the last 7 years, and I have obviously the advent of GenAI is something that is talked about quite a bit in our classes, and I've been experimenting both in my classes and in some of the research that I have been doing as well. I think that wraps up my educational experience. I will pass it back to Deepak.
Well, I guess I got disconnected for a moment there. Well, thanks, Michael, for stepping in. Let's kick off the conversation. And my first question was, what are some of the ways you have used GenAI in your classroom? And Doug, why don't you get us started?
Sure. Thanks very much, Deepak. Good to see everybody here. As you mentioned, I've been teaching courses on computer science and software engineering for decades. And in the last couple of years, I've done a lot of application of generative AI, particularly ChatGPT, in some courses I teach that focus on mobile cloud computing with Java and microservices. And I use generative AI very extensively in those courses. I use them to help come up with programming assignments that I give to my students. I use generative AI to help with the lecture material I create. I use generative AI with the assessments that I do, both in terms of coming up with quiz questions based on the lectures that I have. I also use it extensively to help grade or assess the programming assignments, which has turned out to be a godsend because things are getting more complicated, because generative AI makes it easier for people to turn off their brains and let generative AI come up with the solutions. So I use it throughout my material that I teach, and I also use it extensively in my research. And now more recently, at the Director of Operational Test and Evaluation, we're starting to use it for the work that we're doing, operationally assessing various DoD systems for effectiveness, suitability, survivability, and so on.
Well, thank you. That's an impressive broad range of activities, and we'll come back to some of those. Michael, how about yourself? How have you used in the classroom some of the generative AI tools and services?
So I've been a little bit more cautious than my colleague Doug. I have every semester since it has been a big deal, we've done exercises in the classroom. I've mostly used them in a more I've had the students do exercises while I'm present, so I can be there to help answer questions and observe how they're doing it, mostly so I can learn about it. I do allow the use of GenAI in my classes for large projects. I just ask them to cite it, and there's no penalty if they do. And I would say probably around half the students end up using it, and the other half don't tell me they don't use it. But there's no penalty for reporting or not reporting, so I believe that's about correct. I've been a little bit hesitant to incorporate it as a required part of the course for various reasons that maybe we will touch on in the future, but we have definitely been experimenting with it. I've also been doing some research around undergrads and their usage of it in a more structured research context.
So let's then maybe get directly to the point for my next question. In what ways can software engineering education take advantage of generative AI tools? And here, I guess we're taking a positive perspective. We'll definitely come to the skeptic perspective. Let's go again in order. Doug, why don't you get us started?
There are lots of things that we do as software engineers and software developers that are tedious and manual and error prone. And so one of the things I've tried to do, both in terms of the teaching and the research and the actual practice of software engineering and software development, is try to find activities that are boring and mundane that can be turned over to some extent to generative AI under heavy oversight and guidance on my part, of course, or my TA's part. And so we do things, for example, like documentation, LLMs and various plugins like Copilot or Code Whisperer are very effective at being able to help document the code. They're also very useful for other activities that you have to deal with, like trying to figure out build dependencies and configurations and what parts of the code that you want to refactor. Generative AI turns out to be very effective these days, especially with newer versions of ChatGPT, at refactoring code, as well as taking code and finding ways to have it split into platform-dependent portions and platform-independent portions in order to make the code more portable. There's lots of other ways it's useful as well, but those are just some of the ones that I use in the courses that I teach.
Michael, how about you?
Yeah, so we have found that teaching architecture to students is not always the easiest thing in the world. And so one of the ways we've been using it is we've been using it as a black box that students have to architect into a larger system. And this has gotten students much more excited about the architecture assignment than they have ever been in the past, despite the fact that it's not maybe really using all of the possible value of GenAI, but it has been something that students have responded quite positively to. We also encourage them to use it heavily for, language constructs for new languages if they're not familiar with Python when they come into our course, to use it to help answer that. But ultimately also we are trying to start teaching in our classes, because I am a firm believer that software engineering classes should prepare students for the realities of the real world that exist out there. And I think it would be irresponsible to teach a software engineering class at this point and pretend like GenAI doesn't exist in the real world.
Well,
something else I want to just throw in real quick. So I teach a lot of courses that involve the use of Java. And many of you know Java is open source, which means you can take a look at the source code. One of the things you'll discover when you look at the Java source code, however, is it's often not very thoroughly documented, other than the comments above the method names and the class names. So oftentimes when I'm confronted with a large amount of Java code that's quite interesting, but very complicated and difficult to fathom what it does, I'll use tools like ChatGPT or Claude in order to be able to do code explanation and summarization. And it's actually quite useful for that, in order to understand this wonderful code that would otherwise be opaque and mysterious to my students or myself.
So I'm wondering how different kinds of students interact with this. And I know we have quite a number of educators in the audience as well. Please do feel free to type your questions or comments in the chat, because we're also monitoring the chat and we'll be bringing in your perspectives into the discussion as well. But going back to how students interact with these, especially as you said, Doug, when the code is not as documented and you can use a tool like ChatGPT in terms of code summarization and others, how are some of the different usage patterns play out for different kinds of students? And I know you both have experience, but we were going through with that with you, Doug. So let's hear from you. And sure. I know Michael has a lot of experience as well.
Absolutely. So in my experience, the students who are better programmers are often much more adept at being able to use these tools effectively. This is one of the things I know we're going to talk about here shortly, is what's the right time to introduce generative AI in a computer science curriculum. And one of the challenges is if people don't really have a good mastery of problem solving and programming, they're going to have a hard time knowing when the LLMs are hallucinating and producing gobbledygook code. Now, one of the nice things you have with code is if it's truly gobbledygook, it won't even compile. But there's also other subtleties where it will compile, but it won't be correct. So in my experience, the students who are already good programmers are usually much more able to figure out how to apply these tools and techniques most effectively and most suitably, because they understand what to look for when it starts to go off the rails and hallucinate. So that's been one of my experiences. And I'll let Michael go, because I'm sure he has other perspectives on this.
Yeah, so this is something that I have thought a lot about and actually done a fair amount of experiments in my classroom around. And so I am a firm believer that I want everyone in my class to be successful at software engineering. And this is something that's very important to me. And in a lot of the research, there is a correlation between a student's success and their sense of self-efficacy, right? This is how efficacious, how good they think they are. And this is often can be independent of their actual skill level, right? And it has commonly been studied that oftentimes students from underrepresented groups, or maybe that are somehow kind of different than what they perceive as the average student, might feel that they have lower self-efficacy than other students, right? And in some of the experiments I've done in my class, I have noticed a trend where it seems like the students who have lower self-efficacy often struggle with the LLMs, especially when they give them code that is wrong, right? Because there is this kind of cognitive hurdle to essentially you have to say that the artificial intelligence is wrong and I am right, right? And so if for an experienced programmer who looks at the code and can automatically identify that, yes, this code is actually gobbledygook, I feel comfortable making that judgment. Sometimes for students, they have a hard time doing that, especially it seems like if they are maybe from an underrepresented group. Since they are my students in the class, I know, who's a good student. I have final grades and all this thing. And in my experience, students' ability to kind of overcome that inertia is not necessarily dependent upon their actual skills and abilities as a student, and often seems to correlate much more with students who maybe don't look like everyone else in the classroom. And so at the same time, there are students who use these tools. It absolutely supercharges their ability, right? It makes them much faster than they would be without these tools. So I guess I have concern that we don't fully understand the behavioral patterns, and we don't understand the relationship between behavioral patterns and maybe the demographic groups of the students, and important concepts like self-efficacy, actual efficacy. And so this is very concerning to me. I'm worried about a world in which the rich get richer and the poor get poorer with these tools, right? So I don't think that they will have zero impact. My concern is that they will disproportionately help the students who are already kind of ahead, and will grow the gap between the students who are ahead and the students who are not ahead, or don't see themselves as being ahead, even if they are still really good students.
Well, I think this also has implications for after graduation as well, because if you're ahead, that also opens up more employment opportunities for you, or more alternative opportunities in terms of your skill sets and career growth, versus if you're not. And that also has implications for software engineering in the different kinds of contexts as well. We have a question that came in, so let me take that question because this is related. It's from Ricardo Siciliani. Does any students in your course ask if it's worth to learn programming? This is an interesting question.
I get that question all the time, and not just from students in my class. I was taking an Uber ride the other day, and the Uber driver heard me talking about software, and he said, I'm a computer science student at a university in Tennessee, and is it even worth being in software and development? And I think the answer is a resounding yes. And for one reason, if no other reason, there's going to be a lot of really bad generated code created by LLMs, and we're going to have a lot of technical debt incurred by this. And so rather than having fewer programmers, we're actually going to probably ultimately need more programmers, because people are going to be trying to solve much more interesting problems. That sometimes the LLMs are going to do a good job, sometimes they won't, but we're going to create an enormous amount of new software. And that software is really not going to maintain and sustain and evolve itself. So there's so many opportunities. And I think what's going to happen also is people's appetite for more interesting applications is also growing very rapidly. And there's going to be a surge of demand for people who know how to navigate these tools and use them effectively to create business value for the users.
I get that question a lot too, if I can quickly comment on it. This is where I love to point out that there is a difference between software engineering and programming, right? And I think how programming gets taught will necessarily have to evolve over the next few years, but I think absolutely software engineering skills are absolutely not going away. I like to talk about Jevons paradox, which is an economics law that states that an increase in efficiency and resource will generate an increase in the resource consumption rather than a decrease. So to kind of put that in simpler terms, if you think about, word processors and email have made paperwork easier to generate, it hasn't resulted in less paperwork than there was in the 1940s. It's resulted in a lot more paperwork than there was in the 1940s. So will programming look exactly the same now as it, in 10 years as it did 10 years ago? Probably not. But will software engineering skills be as valuable or more valuable in the future when all these people have all these large piles of code that they don't fully understand? Absolutely.
Well, I think it's probably safe to say we're probably entering the golden age of software engineering. While the tools might look different, it's actually, I don't think I personally seen so many people who are not software engineers talk about software engineering. That's also another indication. I think that is changing. We have another question, which is also related to expertise related question that I was about to ask. It comes from Lynn Robert Carter. And his question is, LLMs typically cannot provide the derivation behind what is produced. Can the LLMs produce code so those who follow know the why with respect to the design and the requirements? And my question related to this is, this also goes to the expertise. How do we instill the expertise if we're relying on the tool, and be able to educate the students accordingly? So do either of you want to jump in?
I'll take a first shot at that. I'm sure Michael will have more than 2 cents worth to add. So I would actually sort of take issue with the idea that LLMs are not good at analyzing or summarizing or providing a rationale. Like I said before, using the example of the open source Java code base, I find LLMs are way more effective at being able to make sense out of large amounts of code, at least at a high level and often at a very detailed level, than certainly most of my students are, and oftentimes myself, because I don't have infinite time to spend trying to decipher some obscure piece of code. So oftentimes when I find a piece of code written by my students that I find hard to understand because they haven't commented it, for example, I'll often run it through ChatGPT and it'll give me a very good synopsis of what's going on. And then I can focus in on the parts that need more human insight in order to make sense out of. So I think LLMs are already very good at this. I think they're going to get much, much better at this as we get optimized and fine-tuned models here that are focused on software development.
So related to that, though, we talked about some of the potential risks in terms of making the rich richer, poor poorer, and also relying on the tool rather than understanding some of the inbuilt mechanics. So how do we address the concerns in terms of the shortcuts that the students might make that become habitual and might hinder their becoming experts in different kind of areas in software engineering?
Michael, do you want to go?
Sure. I mean, I think this is the biggest question I think that we are facing, right? This is, to me, the million-dollar question. And I'm very, very concerned about this, right? And just to kind of mention, we talked about this earlier, that with the rich getting richer and the poor getting poorer. And I also have been hearing from friends in industry that they see that experienced developers get sped up, junior developers, don't see the speed ups, right? So this is something that a lot of other people are observing. I think this is a really, really important question. When I was in school, everyone took a compilers class. And now, lots of people aren't taking compilers classes. Most people aren't writing assembly language code anymore, right? And part of this is because we have, as an industry, moved above that level of abstraction. But we have been able to do that because, in my lifetime and all of the, probably hundreds of thousands of bugs that I have written, I have never personally encountered the case where my code was correct and it was actually the compiler that was wrong. Now, I'm sure if I was on a compilers team, that would have been different, but I was writing high-level business logic code, and the compiler is essentially never wrong at this point, right? And when they are wrong, it's usually an implementation problem, not a conceptual theoretical problem, right? So I think there is a view that the LLM becomes like a compiler, and we just operate at that level of abstraction. But I don't know how we get there, given the guarantees of correctness that we can never have with an LLM, right? And so, given that, we are all human. We're often going to take the path of least resistance to finding the solution. This is what programmers have prided themselves by doing for many, many years now, is finding the laziest solution to get the code to do the work for you. So that's something we value as a community. But then how do we still help people learn in a world where the answers are kind of easily given, when we know that, based on what we know about human psychology, that will not actually help their learning? They won't actually internalize it. And just seeing a correct answer doesn't help you learn, like struggling through and working out the answer on your own. So this is, I think, is a really, really important question. I wish I had a magical answer that would solve this problem for everyone, but I think we don't. And I think it's really something that we as a whole industry need to wrestle with coming forward.
I'm going to take a little different shot at this question. One of the things I find quite fascinating about LLMs, especially the newer ones that are less prone to hallucinations, is you can use them, and I encourage my students to use them as very low cost but very high fidelity 24/7 tutors to go back through, for example, my lectures. I videotape all my lectures and then I post them online on YouTube. And then I encourage my students to go back and use tools like GLASP, G-L-A-S-P, which is a plugin for Chrome, where you can take a look at the script of a video, and then you can ask questions. And this is what I do to tell my students how to prepare for quizzes that I give them. I say, go and use the LLM to query my lectures and find out what kinds of things I talked about, and then quiz yourself to see if you really understood what I was going on about. And I think we can use tools like ChatGPT and others as these tutors to help us understand things in ways that would be otherwise untenable without having 24/7 access to TAs or faculty. Now, this, of course, is also premised on the idea that LLMs are fairly accurate. And if you give them content to work from, like my lecture transcript, they're actually quite accurate. It's when you start asking open-ended questions with the early versions you have problems. But I think that it's actually a great way to democratize access to knowledge, because people can use these tools as basically, like I said, a tutor or a coach to get insights that people would otherwise get frustrated with if they had to do this for long periods of time as a TA or a faculty member in office hours. So just aren't enough hours in the day for me to answer all my students' questions. But ChatGPT and other tools can be very patient and answer them quite nicely.
There are a number of interesting questions related to the conversation we're just having. So let me ask a couple of these. Paul Emerson asks, on the practical side, when you suggest or recommend the use of AI in the coding tasks, do you suggest that the students use 2 or more tools in order to compare the outputs and more easily spot hallucinations? So have any of you done that?
What I encourage people to do is use the paid versions of the tools. I remember when we first started working, thinking it was just a couple of years ago with ChatGPT 3.5, it was notoriously inaccurate and would give you all kinds of strange results. With the new version, ChatGPT 4.0, it's much more accurate. Now, as for having multiple versions, that's a great way to go. And I have done that myself in my own work. I don't necessarily recommend it to the students, but if they have access to that and they're willing to get paid versions for more than one LLM, it's a wonderful way to get a sanity check of what otherwise can be a rather risky proposition.
So related, do you have anything to add, Michael?
Being a software engineer at heart, I always tell them to write unit tests. And if the code passed the unit test, this is a great way to know that you should, incorporate it into your project or not.
I know quite a number of people applauding that answer now, Michael, but yes, that should be default, and then do what else. Another related one, this is an interesting question from Mark Mahoney. Has anyone noticed that their students are not using AI as much as one would expect? Are there any theories as to why? Or is there like everybody's excited because of the fear of missing out?
I think this is also a generational thing. I think the first year or two that it was out, a lot of people were reluctant to use it. For one thing, many other faculty and many other disciplines, including computer science, told them not to use it. So that's one of the issues. And secondly, there are some people who are just more cautious than others. They don't necessarily want to break things. They don't want to try something that they're not sure if it's going to work. So there definitely is a bit of caution there. And I think it goes back to what Michael was saying before about self-efficacy and people who feel confident in their abilities. At the other end of the spectrum, though, I have some incredibly smart students who try to do everything with LLMs just on a lark, and they'll have all kinds of problems. But it's interesting to watch them wrestle with it and learn the prompting patterns and the prompt engineering necessary to get the tools to do their bidding. I think that's a very important part of the education process too.
Okay.
Yeah, I totally agree with that. I think a lot of this is kind of people's risk tolerance, right? It's very risky to get this code that you may or may not work and throw it into your system and see what happens. And some people are comfortable with that. I also think it is dependent upon people's comfort levels of reading code and understanding code. And I personally think one of the things that's going to really be a hugely critical skill going forward is that we're going to have to be much better at teaching students how to read and evaluate code, which is something we traditionally haven't done a lot of. And if people feel comfortable looking at a piece of code, reading through it, and identifying what they think it's going to do, they feel comfortable using it. And when they don't feel comfortable doing that, they don't feel comfortable using it. And when I ask students, why didn't you use an AI tool? Almost always the answer is, well, it's either I was afraid because I thought I would get arrested for cheating. As Doug mentioned, sometimes people get scared. But the other, by far and away, most common answer is it spit out all this code. I started reading through it. I didn't really understand it. And I didn't want to just add it into my program without understanding what was going on. And it was almost always this kind of risk aversion seems to be the root cause in my experience.
That's interesting. So there's also, first of all, thanks a lot, our audience. I really appreciate the questions, and I'm trying hard to keep up. And there's another interesting one. How can the instructor give the credits to an assignment or project whether if it's been solved by ChatGPT?
Well, this is a problem that's bigger than ChatGPT. This has always been a problem. Anytime you have a programming assignment where people don't do the programming assignment in a clean room with a pen and paper, you have the question of where did they get the code from? I don't necessarily think this is any different than that issue. It's just easier to disobey the honor code if you have the electronic means to do so. I intentionally design my programming assignments now to leverage the use of LLMs. And the way I do that is I write the specifications to be vaguer than I used to. 2 years ago, when I would write specifications, it would be very detailed. And then I've discovered to my chagrin that my students were able to reverse engineer the solutions from my very detailed specifications with high degrees of precision. So now I intentionally write things in a bit vaguer way. and I've come up with all kinds of clever ways to grade those things. We don't have time to talk about that right now. But the point is that you can design assignments with the intent of allowing people to use generative AI in order to be able to fill in the gaps that otherwise would require an enormous amount of effort on their part to do it in the old school manual way.
So
yeah, I do the same thing. I write my assignments vague because I mean, I'm not teaching programming, right? I teach software engineering. So I've always had a policy that you're allowed to use code you find on the internet. You just have to cite it and say that you use some code from Stack Overflow or whatever. And I don't treat, LLM code any differently. And so far it's been working.
So I think both of your answers hint at a very important aspect of these tools and how it might be changing how we're interacting with education, curriculum, assignments, and not. And that's, I think, the skill sets. You both said you write the assignments now vaguer, which is a different skill set that you're going after as opposed to a lot of the specificity that you previously had. So are there new skill sets that become more important to teach to software engineering, computer science students? These can be related to software engineering, in general learning, problem solving, or GenAI. Have you experienced or thought about any of that? Or as you interacted with these assignments and the students, did it bring up, okay, there are these new skill sets that need to be emphasized more than it used to be in the past?
Absolutely. So oddly enough, some of these skill sets are ones we've always emphasized, but sometimes it gets lost in the world of third generation programming language syntax and semantics. So number one is problem solving, thinking clearly about defining what you're trying to do, articulating it in ways that will be as straightforward and unambiguous as possible. That's always been good practice. However, when you start writing in traditional code, you often get wrapped around the axle of pointer arithmetic or linked lists or buffer overflows or things like that. So just thinking clearly is important. I think another very important skill set is learning to do effective prompt engineering, learning to interact with the LLMs to get them to do your bidding as opposed to doing things that you don't expect. Also very important, and I think Michael alluded to this, dealing with uncertainty. You're not going to always get exactly the same results back every time you ask an LLM to do something on your behalf. And also very important that he alluded to as well is chunking your solutions up into smaller pieces. When I ask ChatGPT to generate something for me, if I keep it bounded and fairly well scoped, it's number one, it's usually more likely to be correct. And number two, it's usually a lot easier for me to figure out if it is correct. If I start trying to get it to generate vast amounts of stuff, it does all kinds of crazy things, number one. And number two, I have a hard time knowing what it's doing. So I think those are all good principles of software design that we've used for years. And now this just makes it easier to help to automate that process.
Michael,
so I did my PhD on continuous integration, and at the time it was relatively new, and I went around and interviewed a bunch of people about what's the benefits of CI, and it really turns out the benefit is they just were actually running their unit tests. And before CI, we had 20 years been telling people to write unit tests, but no one actually ran their unit tests, right? And so I think I even said this explicitly before. I agree with everything that Doug said, but we've always told people to read your code and understand it, but I think it hasn't really been a skill that had a reason why it needed to be exercised. But now I think that is going to be something that is really exercised. I think writing unit tests for code that you didn't write is something that we've always taught in the abstract, but people haven't had a practice of doing. But now I think, okay, here's some code. Well, what can I do? Well, I can write some unit tests, and if the test passed, then I feel much better about this code being correct, right? That's a skill we've always wanted people to do, but I think in practice hasn't really been something that has been done a lot. So I think that there's it is going to change how we do things, especially in terms of reading, evaluating, testing code that we didn't write, right? And it isn't trustworthy, right? That doesn't come from my colleague who I know always writes good code, right? So I think we need to kind of have this dealing with uncertainty, always kind of look at code in a little bit slightly suspect manner and think about it thoroughly. Things like mutation testing, that is something that I think could become much more common as a way to much more thoroughly evaluate code than we have done in the past.
And it's interesting. It's not, we never said problem solving was unimportant or less important. It's always critical thinking, problem solving is always important. But now if you're not as good at it, then you have lesser of an opportunity maybe to really be able to use these tools effectively. And that also emphasizes skills that you had to develop anyways. You just cannot escape it anymore. That's, I think, a good outcome rather than a bad outcome. There's another interesting question from the audience that I want to make sure that we get to. It's from Alfreda, and he's asking, software engineering is way more than simply coding. So any examples of how to use AI assistance on other activities like requirements engineering or writing specifications or anything that you could think of?
Perfect. This is, I was hoping we would head this direction. So people have, this goes back again to something Michael just said. If you had a compiler that generated really efficient code, but it was only correct 90% of the time or 70% of the time, you probably wouldn't want to use that compiler. And so point of that is that the baseline, the comparison point for compilers and unit tests for that matter is perfection. And these tools are not ready for perfection yet. However, there's many, many other aspects of the software engineering lifecycle, many other activities, requirements, processes for doing groups of people to look at policy documents to see what the policy should be in certain high stakes, safety critical domains. And these environments, these activities, these upstream phases of the software lifecycle are not something where perfection is the norm. It's usability, utility. It's being more effective than having groups of people sit around eating pizzas and drinking Cokes and being imprecise. So I think there's a lot of opportunities there for doing analysis of large document sets. Again, they could be requirements documents, design documents, they could be architecture documents, they can be policy documents, and then looking for inconsistencies and discrepancies amongst those documents, and then from those documents down to the actual code and showing traceability. And LLMs are actually very, very good at summarization and analysis of documents because that's what they're trained on. So I think there's actually more low-hanging fruit for the upstream activities in software engineering to be leveraged rapidly than waiting for perfection from the code generation and testing part of the LLMs. Not that we shouldn't be doing those things too, but I just think there's more opportunity upstream.
Yeah. Anything to add, Michael?
So I haven't been as successful in these, and maybe it's just I'm not teaching my students how to prompt properly or something. I mean, I would say my architecture diagrams have gotten so much more beautiful since LLMs came out, but also so much more incorrect, like just straight up horribly wrong. So I think a lot of students are valuing the glossy beauty they get out of the LLMs in terms of some of these things without fully engaging with the substance. And so I haven't really cracked the nut on how to get them to really focus on the correctness of the content being more important than the presentation layer. But that's something I'm still actively working on.
It's also important to remind ourselves that the tools will evolve, and sometimes the next generation might perform well on speed, but not well on accuracy. So there's that. We're going through the nimble period of the development of the tools and where the data is coming from. But I think it's while the application scenarios are many, probably programming and code generation is where it's most successful currently, and that might be why some of the conversations are skewed. But I know there's examples, especially research examples, in terms of applying to quite a number of areas. So I would like to switch our gears a little bit to general curriculum design, because we've been always all talking about your experiences in your particular classes, but there's a curriculum aspect of how you incorporate generative AI into the whole software engineering education beyond an assignment or a particular class. So where in the curriculum should generative AI be introduced, in your opinion? What are the most or least effective ways of using generative AI? And I think it touches upon quite a number of the questions that we already talked about, but kind of takes a more higher level perspective in terms of going forward, and should the curriculum start changing, or what does the future look like probably as we experiment with these tools?
I think to some extent it depends on what we're trying to use these tools for. Are we trying to use these for computer literacy, for computer science, for computer programming, for software engineering? For example, we teach a course now at Vanderbilt on basically computer literacy with LLMs, and we focus on prompt engineering and bots and agents. We teach people how transformers work. We teach people how people fine-tune and build models. And that's probably something that's important right now because people coming out of high school don't have that background. I'll bet in a decade, people are going to know that kind of stuff. So teaching those kinds of things as computer literacy may be less important. I think I'll echo something that Michael said earlier too. We need to make sure that our students have good foundations if we want them to be good computer scientists and good programmers and good software engineers. So starting too early by leapfrogging over the painful trial and error period of learning to be a programmer is in the vain attempt at trying to supercharge people too quick. That's probably not the best thing to do. But I also think this is generational. And in 5 to 10 years, everybody coming into college is going to have these basic skills. And so we're going to have to keep rethinking where we introduce it. But I would say computer literacy, great way to do it, but I wouldn't necessarily try to start having people use LLMs in CS 101, for example.
I mean, I think these are a tool, right? And I guess one of my concerns is when all you have is a hammer, everything looks like a nail, right? And so I think the tool usage should be taught kind of where it falls in the curriculum, right? Like when you're thinking about like, you know, requirements generation from a large body of text, right? That clearly belongs in a software engineering class, right? When you're thinking about other things that maybe it belongs in a data structures class or an algorithms class or something like that, right? So I think, I mean, I think we'll clearly we don't know the answer to this yet, and we will have to discover it as an industry. But my initial intuition would be that it should be taught as a tool, as appropriate at the point of use of the tool, right? So you're using this tool to solve some problem or to do something, and wherever that concept is taught as a learning goal in your curriculum, that's where the tool usage to achieve that learning goal should be taught.
So
it's also crucially important to use the right versions of these tools. For example, one of my colleagues at Vanderbilt had an interesting study where he used ChatGPT 3.5 to take his algorithms test. And as you might expect, the first version it basically got like a C-. And I've hoped he would replicate and rerun that experiment using the new versions, because I have a feeling it would probably be more likely to get a B+ instead of a C- now. And in the next couple of years, it'll probably get an A+. So over time, these tools are going to get better at what we want them to do, and then we will hopefully feel more comfortable leveraging them, although we can't get sloppy and start expecting them to do miracles. We have to continue to oversee and keep track of what's going on.
Yeah, and what my favorite quote, Michael, is a fool with a tool is still a fool. So I think there's the tool aspect and how the tool is created aspect, and where you apply the tool, the workflow. So I think there are a number of abstractions that we're dealing with, both from a software engineering education perspective, but also from a software engineer and developer perspective who are in the trenches. And I think those are all shaping as we go. But a question that comes from the audience that is maybe more direct is Paula asks, in the curriculum, do we need a lecture, a short course, or a full semester course on some of these, or such as, like, for example, prompt engineering?
I think I'd look at this the same way we look at other important software engineering concepts like cybersecurity or safety. You can certainly, or ethics for that matter, you can certainly have a dedicated course on these topics, but I think over time it's probably more effective if they become part of the overall curricula. And so, for example, in writing cyber secure code, yes, you can have a cybersecurity course, but you darn well better teach people in their CS 101 course if you use languages like C or C++ to make sure you're careful in avoiding things like buffer overflows. So I think it is more effective if it becomes part of the culture, just like using interactive development environments are now part of the culture. Or in Michael's point, test-driven development. You should be able to do test-driven development for everything once you've learned the basic ideas. And so I feel better about having it throughout the curriculum, but maybe having one or two specialized courses where we dive in more detail about how things work. And those will probably be the AI data science-y courses that we have our students take.
I also think there's a big difference between what do we do in the next couple of years. I mean, most of my students right now started without LLMs and are graduating with LLMs, right? Versus a steady state of 10 years from now, where will we be? I think those questions might have different answers.
That's a very good point. And there's also a lot of evolution and change that we've gone through in the past year and a half, especially. And AI subjects have been part of the curricula in different ways. But I think because we anticipate that evolution and we anticipate a stabilization of some of these tools and techniques to be part of the software engineers tool chain, as well as software engineering education's building blocks, let's look at it from the other perspective. Are there different other classes, not including AI, that need to be now part of the curriculum or part of the courses that was not before? Does existing or introduction of AI, GenAI, bring forth other kinds of concepts that need to be taught that has not been taught before?
Absolutely. And the easiest one is prompt engineering. And that's something that you can use in computer science and software engineering domains. You can also use it perhaps even more effectively in all kinds of other domains where you're not doing software development in the classic way. And I think people also sometimes forget there's more to prompt engineering than just learning parlor tricks and patterns to get the LLM to do your bidding. It's really about a holistic way of thinking through the life cycle of developing non-trivial mission-critical systems using LLMs, and in much the same way that software engineering is a body of methods and processes and tools, prompt engineering needs to be looked at holistically there as well. So I think those are things we're going to have to start taking a lot more seriously. And that's where software engineering curriculum and professionals have a lot to offer this brave new world of generative AI, where it's still kind of the Wild West, just like programming was 40, 50 years ago.
So I think that's an interesting point. I want to kind of take a little bit of a hot take that maybe, I don't know if everybody agrees with me, but that's fine. I think humans are really bad at risk assessment and risk analysis, right? So you're actually more likely to die from a coconut falling out of a tree and hitting you on the head than from being bitten by a shark, right? But way more people are afraid of sharks, right? You're more likely to die from sitting in a chair than flying in an airplane, but who's afraid to sit in a chair and who's afraid to fly in an airplane, right? Humans are bad at risk assessment, generally speaking. And I think that we, by bringing in LLMs and bringing in things like that, we are adding a huge amount of risk to our life cycle development. And I think people don't have a good sense of, probability. What does it mean to have something that's 70% right, something that's 20% right? So I think maybe we will need to help further educate people on risk assessment, probability, statistics. How do you actually take statistics and turn them into a meaningful part of your workflow? I mean, this is something that a lot of experienced professionals are good at, but not something we traditionally teach at the undergraduate level.
One interesting question that is kind of related to this, it comes from Shell from NOAA. She's a NOAA affiliate. And are any of you giving thought to continuing education courses about use of GenAI for deployment in the existing workforce?
Yeah, I think that's actually one of the other low-hanging fruit areas. There's a number of very good courses now on generative AI and LLMs that you can get on places like Coursera. You can even find YouTube videos, but Coursera has some really good free courses on prompt engineering in a wide range of domains. And I think that's another key thing. I know our focus here is primarily computer science and software engineering education, but there's obviously many other disciplines in universities and beyond in the industry and in government who are trying to solve problems with computation. And historically, when people came to us, software engineering and computer science professionals, and asked for help for how they could use computation to solve their problems, we would try to turn them into programmers. And while that sometimes works, it's also not necessarily the best use of their time and of our time. And I think a lot of these people are actually much better off learning to become prompt engineers and using LLMs to do computation. And I find myself nowadays, when I have a computational task to solve, my first inclination is no longer to write a program in Java or Python. It's to see if I can get ChatGPT to do something that will result in a computational result that's accurate and efficient and so on. And that's much more effective for other domains because people don't want to have to learn to write in third-generation languages.
Yeah,
so I'm not
go ahead, Michael.
Sorry, I'm not an expert in continuing education, so I'm not going to address that part of the question, although I think it's important. But I will point out that you asked, I don't know, 30 minutes ago, you asked if people, are programmers going away? And I will say, jumping on kind of what Doug said, right? The most commonly used programming language in the world is Excel, right? And so imagine if every dentist office and every real estate office and every, elementary school has someone who knows how to do prompt engineering and is using LLMs to do calculations for their business, right? This could be, these people are doing this right now and they're doing it in Excel, right? And if those people start using LLMs, the number of programmers isn't going to go down. It's going to go up by orders of magnitude if that happens, right? So I think that's really important. And then the question is, how do we educate those people and teach them how to do it right with things like continuing education is a really, really important question, even though I don't have the answers for it today.
Let me just riff off that a second. I think that's a crucially important point. In fact, when people say programming is going away because of LLMs, I think it is actually the opposite to Michael's point. I think almost anybody who uses an LLM, once they become a sophisticated prompt engineer, is a programmer. They're just not programming languages like Java and C++ and so on. They're programming in natural language LLMs in order to get the results of computational outputs. And it's basically like, SQL on steroids in a lot of ways. So this is actually quite fascinating. And I think it actually goes back to this issue of, are software engineers going to go away? And the answer is absolutely no. We need a lot more people who are prompt engineers and sophisticated software engineers to manage all of this programming that will be done by the masses, because it's going to make a big mess if we don't.
And to the continuing education point, we get that asked a lot at the Software Engineering Institute and Defense Acquisition University and others look into different resources to be able to put into that. But I think an important question, and this was in fact a question early on, is what's the difference between a software engineer and a programmer? I think when we're looking at the implementation tasks, we're looking only a subset of the skills and the tasks that a software engineering project and a software engineer needs to employ. And I think there's a lot more to that this conversation is bringing to bear very clearly. Oh God, this is very exciting. I would like to make sure that we hit on a couple of the points. And then I have two questions that I want to make sure that I ask before we close. So Danny Digg, Michael, he has a comment for you. I agree with your view that reading code is an important skill set, yet most of the LLM applications are authoring code. What new applications can inspire research to optimize the reading is the question that Danny has for both of you.
Michael,
I think that
one.
Sure. I mean, I think this whole idea that I think, we can think of uncertainty as fear, but we can also think of uncertainty as motivation, right? And I think oftentimes it's been hard to convince people to read code or to analyze code because the idea is, well, I wrote it, I know what it does, so why do I even need to read it, right? But now that you have this code that's untrusted coming from an potentially untrustworthy source, it is much easier to motivate students why reading is important. And I think that we have, 40, 50, I don't know how many years of research into code generation tools. And we have these amazing IDEs and all these tools around code generation that are awesome and we use, and I don't mean code generation, but actually code authoring, right, by humans. And we haven't put that energy and effort into researching ways to help people read code, ways to help people analyze code. And so I think as the need for code analysis becomes more obvious and apparent to people, I think this will create opportunities for researchers to step in and find better ways to help people read and understand code, and for help teachers find better ways to teach students how to read and understand code.
One of my favorite things to use recent versions of ChatGPT for is basically as a code analysis buddy. And in my courses I teach when I was a professor at Vanderbilt, myself and my TAs created a tool that we used to do automated assessment of programming language solutions. And we were able to describe through prompts the kinds of things we either wanted the code to do or we wanted the code not to do. And we could describe them using prompts, and then we could run the code through it using a tool we wrote. And it would basically do static analysis of the code and give us the results we wanted. What was most interesting about this was if we had a rule described as a prompt that wasn't getting the answer we expected, we could engage in Socratic dialogue with ChatGPT until it would help us craft the right way to phrase the rule. And just think about that for a second. If you've ever used static analysis tools, have you ever been able to engage in Socratic analysis with your favorite static analysis tool to get it to tell you how to write the rules right? The answer is probably not. And so this is one of the things I find so useful with LLMs is I can work together with my LLM, with my chat buddy, and I get a lot more productive and a lot smarter. And I'm already pretty sophisticated, but it makes me 100 to 1,000 times more productive with very little loss in accuracy because I'm always overseeing the results that are coming out. So there's a sanity check that's going on.
So
I want to keep, just real quick, I want to keep banging the drum of, I think interaction model matter a lot, right? And this whole idea of like, it is intelligence and you have to be better than the intelligence is really hard for some students. I think these presentation models much more kind of on the idea of like Copilot, right? Or I think there will become presentations models where we rebrand the LLM in ways where it's obvious to the student that it isn't always correct. And we get to engage in these sorts of dialogues. And I think small tweaks in terms of interaction models and how we teach students about these things can really go a long way in improving the interaction the students have with the model.
So Chuck has an interesting question, which I'm going to take. Are the current LLMs capable of developing full systems, or do they need to be used to address more focused or limited situations? First of all, absolutely not. They're not capable of developing full systems. They're part of a tool chain, and but the good part is that's fueling a lot of interesting research that provides opportunities for using tools together to improve the overall effectiveness. And we'll stop at that. One question I would like to ask you both is, Are there any concerns about resources and costs, including GenAI in the classroom, especially when we talk about the equity? We have a global audience. Maybe some institutions are better suited, and this is going back to make the richer. There are other aspects of it in that. And what are some of the affordable enterprise level solutions? Have your institutions thought about those?
So we have a Generative AI 101 course at Vanderbilt. And the only thing we require the students to do above and beyond what they would normally do is pay $20 a month to get the plus version of ChatGPT. And if you think about it, that's really not that much more different from having, say, a lab fee. In fact, it's probably cheaper than a lab fee in a lot of cases. It's really not that much more expensive than a textbook. In fact, it's probably a less expensive in many cases than modern textbooks. So I think it's reasonable for the cup of a couple of cups of coffee from Starbucks a month. You can get access to much better resources. But I'm also aware that not everybody could afford that. So it would be useful for schools to have some kind of program that they could provide grants or funds for that. I think it's also worth pointing out that unlike most other things that we do and require of our computer science students, you don't necessarily have to go out and get a fancy Apple or Windows laptop costing thousands of dollars. All you need is something that has a web browser, and you can be just about as productive as anybody else who's got a fancy computer in order to leverage these tools.
Michael,
so I started at a community college that was my first institution. So I'm well aware of the fact that there are different resource students at different places. When I was said the rich get richer and the poor get poorer earlier, I meant that figuratively in terms of self-efficacy, but I think there is an actual concern with actual monetarily the rich getting richer and the poor getting poorer in a situation like this. And I don't want to discount the fact that for some people, $20 a month is not what they have lying around. I'm also very concerned about the fact that right now all these tools are relatively cheap because they're being directly subsidized by huge VC firms, and I don't think that will always be the case. So I could see in a few years the costs going up significantly if they reflected what the actual costs of these systems were. And so I don't, this is something that I have long-term concerns about the sustainability of it as well in terms of can people even afford this? And so I think that, I know institutions like Arizona State have announced that they have made premium subscriptions available to all their students. I think we'll see more situations like this. Textbooks are expensive, but there are things like Pell Grants that do cover textbook costs, which, so I don't know, maybe this is something that eventually will become part of financial aid models. It's hard to say right now, but I think there's a lot of uncertainty going forward.
And there's ethics and energy efficiency, sustainability, and all those considerations within software engineering education and across the board. And yes, we talk about the leading organizations because they've been providing the services, but there's also a lot of work going on in being able to democratize the development of models, having them in smaller ones, and a lot of other small organizations are starting to emerge as well. So first of all, thank you to our audience. This has been a very engaging discussion. I could not read all the comments, but we'll all go back to them, and hopefully it will trigger further conversation as we join the discussion room that was only educators only. But as we wrap up, I would like to ask our last question, which is an audience question coming from Prithvi Raj. And the question is, do you feel the guides regarding software engineering, like Sweebach and others probably, must be updated as GenAI gets involved, but more core concepts remain the same?
I suspect a lot of the core concepts will remain the same. Things like modularity, separation of concerns, information hiding, all the good stuff that we learned from David Parnas and others decades ago. But there's absolutely no question that a lot of things are going to have to change over time. And I think the pace of change is going to accelerate. We focus very much here on students, but there's also a workforce out there, and these are the people I work with every day. And many of them don't have the luxury of being able to go back and start over again and take an undergrad curriculum like many of our students do. So we have a lot of work ahead of ourselves getting the workforce educated. And I'm very excited about that because I think there's a lot of potential, but it's also risky because a lot of those people don't have as much time to devote as a student would, full-time devotion and immersion in learning all kinds of new things.
Michael?
I mean, when I went to school, everyone didn't have computers in their pocket everywhere they went, right? And the advent of pocket computing has changed how we interact with things. There's now different ways to write code. There's different ways that people consume code, but the core fundamental properties are the same. I agree with what Doug said. So I think these guides will necessarily be updated as the tools change and as interaction models change. But I don't think that the foundational things we learned back then are going to be are going to be changed. I think that the fundamental principles of software engineering will still continue to be there.
Well, thank you both. This was a lot of fun, and there's only more to discuss, and I know we could go on at least for another hour, if not more. I really appreciate the conversation, and thank you to our audience for engaging conversations, questions, and the comments. I think with that, Shane, back to you.
Yeah, Ipek, Doug, Michael, great discussion today. We really thank you for sharing your expertise. Lastly, we'd like to thank each and every one of you for spending the hour with us today and the great questions and comments. Upon exiting, please hit the like button below and share the archive if you found value. Also, you can subscribe to the SEI's YouTube channel by clicking on the SEI seal in the lower right corner of the video window. Any questions from today's event, please send to info@sei.cmu.edu. Thanks, everyone. Have a great day.